Okay, so our goal for today is to factor polynomials. And to solve polynomials by factoring. So if we were asked to solve polynomials by graphing, you guys could do that because you guys were able to locate the zeros. Okay? So it's the same idea as what we did with quadratics. If you're solving, you're locating the zeros. So if you have and I kind of broke this down into what to do when you factor. If it has any number of terms, you can always look for a greatest common factor, a GCF, that would go into every single term. Okay? So an example would be something like 2x to the third plus 6x squared plus 4x. Let me zoom in on that. Okay. What would be the greatest common factor between 2, 6, and 4? 2. So we'll pull a 2 out front. What's the greatest common factor between x to the third, x squared, and x? X. Okay, so 2x would be our greatest common factor. So then what's left on the inside if we factored that out? 2x times what would give you 2x to the third? Well, it would have to be a 1 because 2 times 1 is 2. X times what would give you x to the third? X squared. So we know that that first term is x squared. There's a plus sign. 2 times what would give us 6? 3. X times x would give us x squared. Plus 2 times what would give us 4? X times what would give us x? Just 1, right? So that would be my general case of factoring with a greatest common factor. That would work with any number of terms that it has. If we have 2 terms, there are a couple different cases here. 2 of them are going to be new. One of them is going to be old, something that we've done in the past. So this would be the difference of 2 squares. So if I had a squared minus b squared, it is a difference because it's subtraction. Okay? This is the general case, so I'm just putting variables there. Okay, I'll show you an actual example on the board in just a minute. Okay, if I factor this will factor to a plus b times a minus b. Some of you, when we were working in quadratics, if I gave you something like x squared minus 49, you guys were like, whoa, 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 Mrs. Fox. There is no x term. What do we do? What is the x term there? There's a 0x term. So it's the same thing as saying x squared plus 0x minus 49. And from there, you worked on like unfoiling it, right? Factoring it. So what times what would give you x squared? X times x. Okay, now your last times your last has to multiply to negative 49. So it's a trial and error here, because from there you'd have to do the outside times the inside, or outside plus the inside to figure out which one is going to give you 0x for that middle term. The only option that ends up working is a positive 7 and a negative 7. Those multiply to the negative 49. Now if you foil that out just to verify that we factored it correctly, x times x is x squared. Outside would be minus 7x. The inside would be plus 7x. and last will be minus 49. The 7x's end up canceling, which is x squared minus 49, which is exactly what we started with. So this would be your standard form. This is your factored form. They're equivalent. These are the exact same polynomial represented in different ways. It's kind of like those nicknames we talked about. If your name is Thomas and I call you Tom, you're still the same person. It's just two ways to identify you. Okay? So that's kind of your example of something that we've seen in the past that looks like that. This is the general case with just variables. So we have two new ones, though. These new ones are with cubic numbers. Okay? It's either the sum of cubes or the difference of cubes. Now, there is no sum of squares. It doesn't work. Now, because this is all your stuff is open note, you don't have to worry about memorizing this. However, you do have to know how to use it. Okay? So a cubed plus b cubed is going to factor into a plus b times a squared minus a times b plus b squared. Now, I'm not going to go into too much detail with this right now because we have some examples that we're going to do on the back once we get through the front side, and we'll use these on the back. The difference of cubes will be if you have two cubic numbers and you are subtracting them. Cubic numbers are like 2 cubed is 8, right? What's 4 cubed? You guys all have calculators there. What's 4 cubed? What is it? What's 4 cubed? 4 to the third power. 64. So 64 is a cubic number. What's 5 cubed? 5 cubed is 125. So 125 is a cubic number. Do you see what I'm getting at? The same way how we come up with perfect squares, that's how you can come up with your list of perfect cubes. Okay? So A and B are both, these two values are both cubed, showing us that this is a cubic number and this is a cubic number, and we're taking the difference of them. When you factor it, it factors into a minus b times a squared plus ab plus b squared. Both of these only have one subtraction sign in them. This one's here, this one's up front. All right, so if there are 3 terms. You have 2 cases. You have the general trinomial, where a is 1, where it's x squared plus bx plus c. And if you have that, where your a value is 1, then this will factor, and you know your first times your first has to be x times x. Okay. This will be a number m, this will be a number n. And we know that when we take m times n, it would have to equal that c value. And we know if we take our outside and our inside, you're going to have nx plus mx. That has to be bx, meaning that m plus n has to equal b. It's just that unfoiling process that we talked about. Okay, you're just factoring it. Foil it and make sure that it actually equals x squared plus bx plus c. Whatever those numbers are, no big deal. You can foil it, multiply those 2 binomials to verify that you factored it correctly. Okay. Now, we did not go into the other methods. We used guess and check. I'm going to write this out. And if you're interested, you can do your more research on it. But really, it's just unfoiling. There is a way, and it's called British method, that if a is not 1, and it's written as ax squared plus bx plus c, then what you do is you break apart this bx term, so it becomes ax squared plus an mx plus an nx plus c. So you broke apart the x term into two different terms, and then that actually allows you to solve it down here, which is by grouping. If you have this turns it into a 4-term polynomial, which then you would go into this spot down here. Now, how do you come up with the m and the n? If you take a times c, that has to be the same thing. So take your n numbers, multiply them together. That's what m times n has to multiply to. Okay? You also know that m and n added together has to equal b, because mx plus nx has to be bx. Okay, so you're just breaking apart that bx term into two terms. So this would start as ax squared plus bx plus c. You break it apart into 4 terms. And like I said, I can show you more details on this, but this is just kind of a way to organize our thoughts and stuff. So if you're interested in learning more about British method, I can show you personally. So grouping. What is grouping then? You can resort to grouping if you have 4 terms in your polynomial, like what we have here. Okay, I'm going to write one out. So if I have ax plus bx plus ay plus by, what I would then do is I group the first 2 together, and I group the second 2 together. So I'm adding a binomial plus a binomial. Remember, when we're adding polynomials, if you drop the parentheses, it doesn't mean anything. If we add the parentheses, they also don't mean anything, as long as that plus sign is still in between them. And then what you can do is you can say, okay, how about a greatest common factor in this term? What would be the greatest common factor between ax and bx? X is your common factor, so we'll pull out an x. We're left with a plus b. We still have that plus sign. Now look at this second grouping. What's a common factor between ay and by? Y. So you pull out the y. And you're left with a plus b. And then I call this the, woo, magical matching parentheses. Woohoo. Oh, yeah. See how the parentheses match? So now it's like we have 1 term, 2 terms. They both have a common factor of a plus b, so we'll pull that out front. And what's left is x plus y. So you then factored it. It's now 2 factors that are multiplying, but that's how we went from a 4-term polynomial into factors. Okay. The only reason I showed you that is because if you want to learn British method, that's how you'd have to do the second part of British method. Okay. As I said, the ways that I've taught you before on how to factor, using our general trinomial and just multiplying it out and seeing if it works. The guess and check way always works, so we can always go by that. So, 2 examples here. The first one is to solve by factoring. So, the first problem that we are given is 27x cubed plus 1 equals 0. Now, this is the sum of cubes. (27x to the third) is a cubic number. 1 is a cubic number, so it is the sum of cubes, so we have to use that rule. Okay? How many solutions can I possibly have here? Or how many zeros could I have based on my degree? I saw some people with fingers. 3. My degree here is 3, so I can have 3 solutions. So that's what I want to make sure I find are 3 solutions here. Okay, Okay, that's kind of my hint. I need 3 solutions because my degree is 3. Okay. Now, looking at the rule says if I have a cubed plus b cubed, this factors to a plus b times a squared minus ab plus b squared. That was my rule from the front. I just rewrote what I had on the front. Right here. Written on the front. Just rewrote it. Are we okay so far? That's the rule I'm going to go with. So, what do you cube to get 27x to the third? What would you cube to get 27x to the third? What do you cube to get 27? What can you take to the third power and your answer will be 27? 3. So our a value is 3. What do you cube to get x cubed? X. So your a value is 3x. Okay? What would your b value be? What do we cube and come out with 1? 1. So your b value is 1. So what we're going to do is we're going to fill in this as our factored form on the left side. So we have a plus b. A is 3x plus b is 1. Okay, I never look at the sign here because the difference with the sum tell you that. You always look at the number to figure out what a is and the number to figure out what b is. Your a and your b value, always keep them positive. Okay, because we already know that these are all plus signs except for that middle minus sign right there, that subtraction sign. All right, so what's a squared? What would 3x times 3x be? 3x times 3x. 9x squared. What would a times b be? Because I know this is a subtraction sign. What would I get if I multiply 3x times 1? 3x. Then I have a plus sign. And it says b squared. So what is 1 times 1? 1. There I have my two factors that multiply to 0. Okay. Now, the reason why we do factored form, just like back in quadratics, is because if two things multiply to 0, it either means that 3x plus 1 equals 0, or it means that this factor, 9x squared minus 3x plus 1, has to equal 0. I don't know which one equals 0, but I know one of them would have to be 0 in order for those two things to multiply to 0. That's why it's beneficial to put it in factored form, because then you know one of the factors has to be set equal to 0. This is just a linear equation. You guys know how to solve that. You've been solving it for years. What do I do first? Subtract 1 on both sides. Then what? Divide by 3. X equals negative 1/3. So far, I have one solution. Okay? If I had to figure out the approximate solution there, I'd go to my calculator and I would type it in. Negative 1/3 is negative 0.333. Okay? So there's your first solution. How many solutions are we looking for, though? 3 of them. Okay? Your next form is it's a quadratic. Your next factor is a quadratic. So in quadratics, you can solve in many different ways. That's what we learned back in Unit 5. What was the way that always works? What way always works when you're solving quadratics? We had graphing, we had factoring, and then there was that big one that we did at the end that always works. And I sang you a song. Anyone remember? It goes to Pop Goes the Weasel. Oh, that thing. Remember it? What's it called? Yes, quadratic formula. So, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to use quadratic formula to solve this quadratic. Because that always works, we're just going to resort to it. Okay? So, what's our A value here? 9. What's our B value? You're going to go with your quadratic now. We're going to forget all of this exists, and we're just zooming in on a quadratic that we did back in Unit 5. So what's your A value? What's your B value? What's your C value? B is -3, and C is 1. We fill in what we know. X equals, the opposite of B would be +3, plus or minus. B squared will be 9, minus 4 times A is 9, C is 1, all over twice A. A is 9, so twice of 9 is 18. I'm going to fill that in. I'm going to go to my calculator. I'm going to fill in what's underneath this radical there. That's the discriminant, if you remember that term. -27 is what's under there. So I have x equals 3 plus or minus the square root of -27 all over 18. How are we doing so far? We feel like we could get up to that part? All right, so then the next part is saying, okay, x is equal to 3 over 18 plus or minus the square root of -27 over 18. But wait a minute. This is where, remember, we can't leave a negative underneath that radical. So we go over here to our scrap paper and we say the square root of -27. I have to simplify that. So how do I simplify this radical? The negative comes out as the I. So I'm going to say I square roots of 27. And then I have to say, okay, what's a perfect square that goes into 27? Perfect squares are numbers like 1, 4, 9, 16, 27. I mean, not 27. 16, and then 25. I was mixing cubic numbers. What's a perfect square that goes into 27? 9. So I'm going to say this is I times 9 times what, though? 3. Okay, and the reason I do that is because now I can take the square root of 9. What is the square root of 9? 3. So I have 3i square roots of 3. And I'm going to replace that square root of -27 with what it equals. So I have x equals, what's 3 over 18 reduced to, though? I can reduce that. 1 over 6 plus or minus. That top is going to become 3i square roots of 3 over 18. So I'm going to write it 3 over 18 I square roots of 3. And you could have filled it in up here too. That would have been fine if you replaced it up here. It doesn't matter where you replace it. That's what we're going to get. But wait a minute, 3 over 18 also reduces. We just reduced it to 1/6, so it's going to become 1/6 right here again too. Okay, but wait a minute. Do I only have 2 solutions then? I have one solution here and one solution here? Is that right? I only have 2 solutions. Aren't I supposed to have 3? How many solutions are right here? 2. Why? What makes this 2 different solutions? Because it's plus or minus. The plus, that's one solution. I could rewrite this twice. I could write 1/6 plus 1/6i squared roots of 3. And then I could rewrite it again and say 1/6 minus 1/6i squared roots of 3. But I don't want to rewrite it twice, so I use a plus or minus and I'm good to go. Is that okay? So I actually have 3 solutions right now. If I had to write the approximate, I'd write x, didn't mean to switch colors, x is approximately, okay, 1/6 is 0.167. Plus or minus, I know this is something I, but I can't type I into my calculator, so I'm going to type 1/6 times the square root of 3 into my calculator. 2887, so 289. 0.289. I. And again, that's still your two solutions. So these are your exact. You have 3 of them. You have 3 exact. And then this is also 3 approximate. Okay, so you have all the exact, all the approximate. All right. The last one I'm going to show you is by using U substitution. Okay, so the problem that we're given here is going to look like a quadratic. It's 3 terms, kind of like a quadratic. Oops, that's supposed to be x to the 4th. Sorry. I was jumping the gun. X to the 4th minus 2x squared minus 8. So it looks like a quadratic, but it's not because it's to the 4th degree. How many solutions will I have? 4. Always look at that and identify right at the beginning. I should have 4 solutions. Okay? Since this looks like a quadratic, we can say that U equals x squared. And then we're going to use U substitution here. And I'm going to show you this next step. You do not have to write in your actual assignment. Okay? This is x squared squared minus 2 times x squared minus 8 equals 0. X squared squared is x to the 4th. 2 times x squared is the same as 2 times x squared. But what this allows us to do is say that x squared is now just going to be u. So this is the same as saying u squared minus 2u minus 8 equals 0. Well, I can factor a quadratic. We practiced that already. So I go right to factoring. The first times the first has to be u times u. My last times the last has to multiply to negative 8. So I could do minus 4 and positive 2. When I FOIL this, my outside will be 2u. My inside will be negative 4u, which does equal the negative 2u in the middle there. So that's the factored form. Now that it's in factored form, you say, okay, well, u minus 4 could equal 0, or u plus 2 could equal 0. That means u has to be 4, or u has to be negative 2. I'm not done, though, because did I want to solve for u? No. What variable are you looking for from our beginning? X. So now that we know u is 4 and x is negative 2, now we just replace it and say, oh, but wait a minute. U is x squared equals 4, and u is x squared equals negative 2, and from there you continue to solve. How do you get x alone now? Square root both sides. Now this is the part that's often forgotten. When you square root in an equation, you have to remember that you have a positive and negative answer. The square root of 4 is positive or negative 2. The square root over here is x equals positive or negative square root of negative 2. You can't leave the negative in the radical. It comes out as I. So x equals positive or negative I square roots of 2. That is your final answer. Both of those. But wait a minute. Because they're both positive and negative, you actually have 4 solutions there, even though it looks like 2, and we were aiming for 4 solutions. Okay? I know this is a little bit tricky, but try your best. Okey-doke.